Welcome student, this is Distinction Learning Platform, and on this platform you'll find illustrations, revisions, tests, quizzes. For you to be updated with all the videos that will be coming, make sure that you subscribe. Okay, to make the story short, let us begin. So as you can see, this is the preclinical session. We're talking about general pathology. Okay, this is now the second part of the videos. We're talking about cell adaptation to stress. Okay, in the first video, so in case you missed it, make sure that you watch it so that you understand the overview of cell response to stress and harmful stimuli. Okay, so now let us talk about cell adaptation to stress. How do a cell adapt to stress stimuli? Okay, so now what is cell adaptation? So remember that cell adaptation is a reversible change by the cell in response to what the stress stimuli provided by the surrounded environment. So remember that cell adaptation is a what? It's a reversible chain. It's a chain that can be reversible. Okay, but sometimes it's not always that adaptation of cells is always reversible. Sometimes remember that it can be now irreversible, that can lead to cell death. Okay, but occasionally, for most of the cases, cell adaptation is a reversible change because a cell was exposed to stress stimuli. So what are we saying? We're saying that cell adaptation is a reversible change shown by cells due to okay. So cell adaptation is what? Cell adaptation is a reversible change shown by cells due to exposure to stress stimuli provided by the environment. Okay. Now remember that you can ask yourself, why do cells? So if you talk about cell adaptations, remember that cell adaptation can be either physiological or can be pathological. Okay, because there are some certain conditions like hypertension which can be pathological, and the cell can adapt to hypertension as well. And remember that there are some stimuli that can be physiological, and the cell can also adapt for physiological stimuli. So meaning that what I'm saying is that cellular adaptation is not always physiological, it can also be pathological. Okay, so we understand that in details. So now let us talk about the first part for cell adaptation, which is hypertrophy. So a cell can become large in size. So what is hypertrophy? Hypertrophy basically means that increase in the size of a cell. So what is hypertrophy? Hypertrophy basically is the increase in the size of the cell. Increase in the size of the cell, and if the cell increases, remember that also the organ outside is going to increase. Now the question that we can ask is that, why do cells undergo hypertrophy? Why do they undergo hypertrophy? I'm not talking about the causes, I'm talking about the why. Because it's very important, if you know the why, then it will tell you the causes as well. So what's the why? So why do cells undergo hypertrophy? It is because of what? It is because there is what? Increase in workload, as well as and increase in functional demand. Okay, so the reason why a cell hypertrophies or becomes large in size is because of this increase in workload and increase in functional demand. So I'm not going into details, we need to understand what it means workload and what it means function demand, because this is the reason why a cell increases in size. So what is the workload? Okay, workload is what? Workload is the amount of what? Work or activities that is given to the cell. Okay, so it's more like this. So what I simply mean is, if this is a cell, so workload is something like the work which is outside here, the amount of work or an activity, okay, that is given to the what? To the cell. That is what we call workload. And we are saying under hypertrophy, this workload is too much for the cell. So mean that the cell has to become large so that it can overcome what? This workload. Okay. Then what else? What about functional demand? What is functional demand? Okay. So functional demand is what? Now, it's not the work that is coming from outside. So functional demand is the work that is coming from what? From the cell itself. So it's the amount of work that is required by the what? By the cell to produce. Okay. So the amount of work which is coming within, then it has to come within the cell and given out. Okay, so make sure that you understand that. Why am I stressing enough? Because if you talk about the mechanism of action, the mechanism of action targets to decrease the functional demand and to decrease the what? The workload. Because to adapt is to make sure that the cell doesn't get injured. Because if it doesn't reduce functional demand and doesn't reduce the workload, then it will lead to cell injury. So that's the reason why I'm stressing enough on that. And another important point, okay? Another important point is this one. So you can ask yourself to say, are all cells of the body undergoes hypertrophy? So, or what are the important cells that can undergo hypertrophy or that can increase in size? So remember that in the body, the body cells, they are further categorized into three main parts. The first part is what we call labile cells. Those labile cells, so those cells are continuous dividing, what? Like what? The epithelial cells of the what? Of the skin, the epithelial lining of the what? Gastrointestinal tract. So those are what we call labile cells. The second type of body cells is what? We call them the stable cells. So those stable cells, they are like, they are not dividing unless a stimuli comes into, like what? The hepatocyte. Hepatocyte, they don't continuously divide. No, they are just stable, they are not dividing. But if you injure the hepatocyte, they will start dividing. Those are what we call stable cells. Now, the last type is what? Permanent cells. What are permanent cells? Permanent cells, these are the type of cells that do not divide. Very, very important point. So permanent cells, they do not divide. So what are the examples of those permanent cells? Are what? Cardiac cells, and also what? Skeletal cells. So those cells, they do not divide, and those are the good examples of what? Permanent cells. And hypertrophy mostly is what? Experienced by what? Permanent cells, like what? Like cardiac cells or myocytes and skeletal cells. So very, very important point. So make sure that you understand. So we are saying that hypertrophy most of the time it occurs in what? Permanent cells. So I'm not saying it's always in permanent cells. So don't get that misconception. So I'm saying most of the time hypertrophy occurs in what? Permanent cells. Okay, like what? The cardiac cells or base cardiac muscles, skeletal cells or skeletal muscles. But also hypertrophy can also occur in cells that can also divide, and also cells that can also divide. So it can also happen there, like what? In the uterus. Uterus is combination of what? Increasing the size of the what? Cells, and also there is division there. So there's a mix there. So basically you need to understand that concept. It's not always the permanent cells that can undergo hypertrophy. Also labile cells can undergo hypertrophy. Okay, so now this part, now let's talk about the causes. Okay, So what are the causes? So causes can be further categorized into what? Physiological and the pathological causes of what? Hypertrophy. Make sure that if they ask you a question to say, what are the causes of hypertrophy? Make sure that you understand to say causes can further be categorized into physiological causes and the pathological causes. So to take you back, what are physiological causes? Physiological causes, these are like the causes that can cause the body to respond normally, or it's a body response to a normal stimuli. Body response to normal stimuli, these are what we call physiological causes. Pathological causes is because someone is having an underlying what? Disease, like disorder. Someone is having hypertension, so that's a pathological condition. So as long as there's a pathological condition and a cell is undergoing hypertrophy, then that condition will be termed as what? A pathological cause. So now, as wasting time, I'll just talk about two physiological causes and also two pathological causes. Okay, so let's start with the first one. So what is the first physiological what? Cause of hypertrophy? The first one is skeletal muscle hypertrophy. Okay, skeletal muscle hypertrophy, like what? Bulging of muscles, bulging of muscles in athletes and bodybuilders. So this is the first cause of physiological cause of hypertrophy. So we have made the skeletal muscles are becoming large like that due to what? In athletes and also bodybuilders. So those people, they do constantly exercises. So that stress that is experienced by those people is going to stress the skeletal muscles of the what? These people. Then these skeletal muscles will respond by what? By becoming large. Why? Because those people, they experience increase in weight load and also increase in function demand. To counteract that, the skeletal muscles, they are going to become large. Okay, that's the first physiological cause. What is the second physiological cause? So the second physiological cause is what? Smooth muscle hypertrophy. Okay, smooth muscle hypertrophy. So good example for smooth muscle hypertrophy is during pregnancy, the uterus hypertrophy. Okay, so the smooth muscle of the uterus becomes large due to what? Estrogenic what? Stimulation. Remember that physiological hypertrophy comes about because there is a normal stimuli in the body. So estrogen, that's a normal stimuli produced by the what? By the body. And during pregnancy, that estrogen is going to stimulate the smooth muscles of the uterus so that they can become large and ready to accommodate that the incoming fetus in case fertilization occurred. So those are the two physiological causes of what? Hypertrophy. Okay. Now let's go to the most important part, the pathological causes of what? Hypertrophy. So what are the pathological causes of hypertrophy? The first cause is what? Cardiac hypertrophy. Cardiac muscle hypertrophy. So cardiac muscle hypertrophy is due to what? So here I'll put examples of diseases that can lead to what? Cardiac muscle hypertrophy. And remember that if you're talking about pathological causes, you need to talk about one good example of what? At least maybe two good examples of a disease leading to what? The cardiac muscles to become large in like in size. Okay. So the first one is what? Hypertension. So let's talk about left ventricular hypertrophy. So left ventricular hypertrophy. So left ventricular hypertrophy, the left ventricles of the heart, the left ventricle of the heart, becomes large due to what? Maybe someone is having an underlying condition, hypertension, okay, systemic hypertension. Someone is having hypertension, high blood pressure, then can give, so that pressure can give us, can put stress to the what? Left ventricle, and the left ventricle, to overcome that functional demand, to overcome that workload, it's going to hypertrophy, become large in size. The reason why it's under pathological is because of what? There is an underlying condition, which is hypertension, leading to ventricular hypertrophy. Okay, and the other example that I can put here, under pathological cause for cardiac muscle hypertrophy is what? Maybe someone is not having what? Hypertension. Someone is having what? The problem with what? The valves. Maybe the aortic stenosis or aortic regurgitation. Maybe mitral valve prolapse or mitral valve stenosis. So those are the underlying conditions that can lead to what? Cardiac hypertrophy. Alright? Then what is the other cause apart from cardiac? So everything that I've talked about is causing the cardiac muscle hypertrophy. Okay, what else? There is also, again, we go back to smooth muscle hypertrophy. Smooth muscle hypertrophy again. So here, smooth muscle hypertrophy, this is the second cause of what? A pathological causes. So remember that smooth muscle hypertrophy, let's talk about the bladder, the detressor muscles. Those detressor muscles, those are what we call smooth muscles of the bladder. So they become hypertrophy, meaning that they become large in size. What's the main reason? What can cause that? So remember that in the human body, basically in the males, they've got the prostate gland. So the prostate gland can become enlarged. Okay, it can become enlarged. So what do we call that condition? We call it prostate hyperplasia. So prostate hyperplasia, the prostate gland is becoming large like that, and it is obstructing the what? The outflow, which is the urethra. Now, if it is obstructing the urethra, urine can't pass through the what? The urethra. It will start going back to the what? To the bladder. That bladder now, it will start now, it's going to have increased pressure there. Then that pressure will start what? Stressing the detressor muscles there. So now, in response to that stress, the detressor muscles will do what? Will start what? Becoming what? Large in size to overcome that workload. That's the reason why the smooth hypertrophy in what? In the for detressor muscles, because of the outflow obstruction of the urethra due to what? Prostate hyperplasia. Okay, so here the reason why the underlying condition is what? Prostate what? Prostate gland hyperplasia. Okay, prostate gland hyperplasia. Okay, so now we are done with the physiological causes and also pathological causes. Let's go to the mechanism of hypertrophy. The mechanism of hypertrophy. So if you say mechanism of hypertrophy, basically they're asking you the details under cellular level. What happens? How can it lead to what? To hypertrophy. How can a cell become large in size? What are those like a mechanism that happens? Cellular mechanisms. So remember that we need to now to start talking about the stimulus. We need to talk about the stimulus. So the three important stimuli that can cause a cell to respond and become large in size. Okay, so the first one is this one. Let's talk about this one. Okay, so this stimuli is what we call the growth factor. Growth factor. Okay, so I'll talk about the details. So the first stimuli that can make a cell to become large in size is what? The growth factor. The second one is what? Stretch. So we are going to say mechanical stretch. Okay, mechanical stretch. So that's the first and another stimuli. The last one is what? This one. The last one is what? The agonist. So we call them hypertrophic agonist. hypertrophic agonist. So now let me explain. So basically, things that can or stimuli that can cause what a cell to undergo hypertrophy. The first one is what? The growth factor. Okay. The second one is the mechanical stress, and the other one is hypertrophic what? Agonist. So growth factor, remember that these growth factors, they are very essential to what? Any cell. Reason being because growth factors, these are substances that can cause what? That can cause a cell to start what? Dividing. That can make a cell to start making what? Proteins and other things. Okay, so those are what we call growth factors. What are the examples of growth factors? Insulin-like growth factors. We've got fibroblast growth factors. We've got transforming growth factor beta. So those are the good examples of growth factor that will come and bind here on the receptor, which we call growth factor receptor. So this receptor is called growth factor receptor. So we're going to say this one is what we call growth factor receptor. Okay, so that's the first one. So mechanical stretch, then it will just activate the mechanical sensor. So this one is a mechanical sensor. So mechanical sensor. Okay, so basically this, if there is a stretch there, then it will just activate the mechanical sensor. Okay, what else? We've got also hypertrophic agonists. So they are hormones. So we talk about agonists, basically we're talking about a lot of things. So an agonist is just something that will activate a cell. Okay, so now hypertrophic agonists, basically we're talking about hormones. Hormones like what? We have adrenergic agonists like what? Epinephrine and epinephrine. We have those. We have endothelin 1. We have angiotensin 2 as well. So those are the examples of what? Hypertrophic agonists. So what do they come and bind? They come and bind on what? Agonist what? Receptor. Okay. So these three things now, what do they do? Okay, they are going to activate the signal transduction pathways. So these three, they are going to activate the signal transduction what? Pathway. Okay, they are going to activate the signal transduction pathway. So we don't need to specify those transduction pathways here. We will start talking about the specific thing that happens in future lessons. Okay, so just know that this, if the growth factor receptor is activated, mechanical sensor is also activated, and agonistic receptor is also activated. It's going to activate now the signal transduction pathway via signal transduction pathways. Now these signal transduction pathways, remember that in a cell there is what? DNA there. So inside the DNA, so these things, these transduction pathways, there are some substances or particles that are going to be produced, and they'll go and activate what we call transcription factor. So they'll go in the nucleus, DNA, and they activate what we call very important part, which is transcription. So it activates transcription factors. Okay. So this signal transduction pathway will lead to production of what? Certain proteins that will activate what? Or certain substances that will activate what? Transcription factor. Like GATA, so there are a lot of transcription factor. Like GATA3, there are a lot. So those transcription factors, now what do they do? Remember that if transcription factor are activated, they activate what we call transcription. Transcription will lead to what? Now, translation, which is the production of proteins. So basically, in summary, what we are saying is that it will lead to the production of what? The first important part is what? The first important part is growth factor. So it will lead to the production of what? Growth factor. Growth factors. That will do what? That will go back and do that. That will go back and bind to growth factor receptor again. Then what else? It will do three things. The second one is what? It will produce what we call embryonic or fetal factors like what? ANF. ANF is actual natriuretic factor. Okay, so this factor ANF, this factor normally it is expressed in embryo or fetal heart. Yeah, but after birth, this factor is not really expressed, but it is expressed. It is re-expressed if someone now after birth, someone is experiencing what? Hypertrophy from the heart. So the heart now will start producing ANF factor. Okay. Then ANF, what does it do? ANF, what does it do? So this one is a very, very important factor. It will lead to what? It will reduce what we call the workloads. And remember that it is what the thing that we needed, because the main cause, the reason why something was undergoing a part of it is because there was increase in workload. And the ANF is going to reduce the what? The workload, which is a good thing. Okay, what else? It's going to what? Reduce what? Functional demand as well. Mean that increasing the performance of the cell. Functional demand. Decrease the functional demand by increasing the what? The cellular function. Okay, so now the question is, how does it reduce the workload? ANF goes to the kidneys and causes the secretion of what? Salts. Secretion of salt, remember that's going to reduce the what? The plasma, the volume, the blood volume. Reducing the blood volume is going to now increase the workload. That is what it's going to reduce the workload that is expressed by what? Myocytes, which is a very, very important what? Point. What is the other now? What is the other point or the last point? The last point is what? The last point is now production of what? Production of very, very important part. Cellular contractile proteins. So this is the last part. So the last part is what? Okay, so the production of cellular protein now, like ANF, what does it do? But this one just improve the functional, improve the performance of the cell by what? By basically doing just one thing. By reducing here, it just reduces the what? The functional demand only, not the workload. The workload is provided by what? By the embryonic fetal factors like ANF. But for cellular contractile protein, they just reduce the functional demand. Okay. So now, since we've talked about the mechanism of action, basically, if you talk about it in general, if you talk about the mechanism of hypertrophy, is what? Increase what? Production of what? Proteins. Okay. What else? Also increase in what? Production of ANF, and also increasing production of what? Growth factors. So this is the mechanism of what? Hypertrophy. The cellular contractile proteins is going to increase. This, if the proteins are increasing in the cell, then the cell will become large in size, and those proteins are going to reduce the what? The functional demand, hence improving the performance of the cell. Okay. Growth factors, what do they do? ANF, what does it do? Remember that now this one do two many important things. Decreases the workload and also decreases the functional demand. Remember that for it to decrease the workload, it does what? It goes to the kidneys, and what does it do? It's going to make sure that the kidneys start secreting what? Salts like sodium. And remember that sodium, water follows this sodium. So it secretes salt, and also the fluid will be removed by the kidneys. If you remove the fluid from the body, then the workload is going to decrease. Lastly, growth factors. Growth factors, they what? they're going to be produced because of these all things that we've talked about, this transduction pathway that we've talked about. And if they are produced, they'll go again bind to the same receptor, to the growth factor receptor, and also promote the further signal transduction pathways. Okay, now on the last part now, since we've talked about the mechanism of hypertrophy, what can we talk about under morphology? Morphology basically means what you can see from outside. So we have two ways in which you can see an organ or a cell from outside. So you either see that using our eyes, so that is gross. If you're using your eyes, that is gross morphology. So that is gross morphology. So what can you see if you are using your eyes? What can you see? Basically, you're just going to see an organ enlarged in size. That's so you can't see a cell using your naked eyes. So what can you see on gross morphology? You can see size of an organ going up. So size of an organ going up. Increase in size of what? Organ only. Then what else? If you want to look at a cell, what do you use? We use microscope. So on microscopy, what do you see? Microscope, what do you see? Now we see increase in size of what? Cells. Okay, and basically tissues. You can add on tissues as well. So that's what you can see on morphology, gross morphology, and microscopy morphology. Okay, so that's where we end from under hypertrophy. Okay, thank you for your time, and make sure that you subscribe so that you can be updated to all upcoming videos.